Okay, so the recording has begun. It is now 11 o'clock. We will go ahead and get started. Let me go ahead and share my screen so that way we can do this. So before we get going, let me also talk about two quick things. Jack, already on the money, asking for question 11. We will go over homework questions in just a second. So sure, we'll start with number 11. So two things. Number one, I know that I owe you guys back your quizzes from last week, and then obviously there was going to be a quiz today. So there was going to be two quizzes that I owe you guys back. Expect to get all of that back this weekend. So my apologies in not returning to you the quiz from last week. This week has been very hectic, to put it lightly, for me. So I never had a chance to sit down and grade all of them. And again, as you know about me by now, I like to grade all of the quizzes before giving them back because I feel like that way it's most fair to all of you. And in that same breath, your Blackboard grades will also be updated this weekend because hopefully by this weekend you guys will have sent me your midterm corrections. Again, midterm corrections are due tomorrow night, right? So the cutoff is tomorrow, 11:59 p.m. I'm not accepting any more. So make sure you get it to me by tomorrow so that way I can, correct, I can, increase whatever, your grade is for your midterm. So yeah, just expect to get back a lot of stuff from me. I might not specifically be able to send you back your midterm corrections, depending on how many I receive, or the amount of grading that is actually necessary for it. If you guys send me your midterm corrections and they're all correct, then that really reduces the workload that's on my end, because then I just have to write, oh yeah, you got everything right, check marks, and you're good. But if there's still some things that are incorrect, then obviously I need to notate that. So midterm corrections, I might not get back to you until later next week, but expect back at a minimum last week's quiz and this week's quiz. Also, so the second thing is Blackboard was fighting me last night when I was trying to put the quiz up for today. So if there's a problem with the quiz, just let me know as far as, like you viewing it. I don't think that there should be, but it was like for whatever reason preventing me from uploading a quiz several attempts in a row. So hopefully it's resolved now, but that was an issue, and I am slightly concerned of it showing up today. So we'll see what happens in about 20 minutes, 25 minutes. Okay, so with all that being said, let's jump into the homework questions. So number 11, let's see what number 11 is. Okay, so number 11 was just a couple quick questions regarding definitions that we briefly discussed in the lecture. So it asked us for the given function to find the highest degree, the leading term, and the leading coefficient. So first, let's write the function. We have f of x is equal to 2x cubed plus 7x, and it's all being divided by 3. Okay. So the only trick here is recognizing that if you have multiple terms in your numerator being divided by, all being divided by something, you can split it up into several fractions. What do I mean by this? If you had, let's just say 1 plus 2 plus 3 divided by 7, this is the same thing as if you split it all up into 1 over 7 plus 2 over 7 plus 3 over 7, right? And we're normally used to seeing it go this way. We're normally used to having, okay, we need to find a common denominator, and then once we have a common denominator for a fraction, then, we throw it all as one single denominator and we add or subtract the numerator, right? That's how we add or subtract fractions. But we can go backwards. If we start with this, where we have multiple terms being divided by one number, you can just go in this direction as well. You can go to the right and say, okay, well, if I have multiple terms up top being divided by a number, that's the same thing as if I just divide each of those terms individually by that number, and then I keep whatever the signs as the same. So if I have a plus here, then it's a plus here, right? And you can freely go back and forth. That's what the equal sign tells you. So instead of it just being regular numbers, we have, some x's going on in here. We have an exponent, but that really doesn't change how we treat this. So 2x cubed plus 7x all divided by 3 is the same thing as 2x cubed divided by 3 plus 7x divided by 3. Okay, so we're almost done. Well, we already just figured out what our leading term is going to be. Our leading term is going to be this guy, right? Our leading term is always our highest power. And that also answers the other question, which is what is your highest degree? So your highest degree is going to be 3, because your highest degree is always the highest power of your function. So highest degree is 3, as opposed to the x to the first power. So that's the one that, doesn't count in this case. Your leading term is always going to be the term that involves your highest degree. So that's going to be this whole thing right here. And your leading coefficient to that leading term. So your coefficient is obviously going to be the number that's being multiplied against your variable, right? Okay, so because we know that multiplication and division are on the same order when we're talking about order of operations, that's, talking about PEMDAS, if you have 2x cubed all divided by 3, this is the same thing as if you had just 2/3 times x cubed. If you divided the 2 first by the 3 and then multiplied by your variable, that's going to be the same thing as if you multiplied your variable by 2 and then divided by 3, right? Multiplication and division are on the same order, so you know that you could freely either divide the 2 first by the 3, or you could divide the you can multiply by 2 first and then divide by 3. So as a result, we know that it's really our leading coefficient is 2/3. So leading coefficient, again, just going to be 2/3 here. Does that answer your question, Jack? Does anybody have any trouble with this now that I've gone over this? I just want to make sure we're all on the same page.
I just wanted to clarify, you said that the leading term is the whole 2x to the third over 3, right?
Correct. The leading term is the entire thing. The leading coefficient is just the number in front of your variable.
Thank you.
Yep. Any other questions? Okay, cool. So we're done with this one. What other questions do you guys have for me on the homework? So that was number 11. I specifically said by the end of the lecture video, I would keep this homework kind of light, so that way you guys had an opportunity to do your midterm corrections and whatnot. So hopefully this one wasn't terrible. 36. Okay, sure. All right, let's take a look at 36 here. Okay, so 36, we're starting with the given function. F of x is equal to 3 times x plus 2 squared times x minus 3. And what we have to do is we have to find all the real solutions and state their multiplicities. So essentially what that tells you is you're trying to find all the x-intercepts, right? Then you have to find whether the graph crosses or touches but does not cross the x-axis at each solution. So what that tells you is that you're going to have a particular solution or solutions once you find the first step, right? So you're going to find all the x-intercepts, whether there's one or several, you're going to find those first. Then once you do that, you're going to use IVT, as I specified in the parentheses, to see whether or not the signs flip. If the signs flip, then it crossed the x-axis, right? Remember in the lecture video how I used that really rudimentary example where you cross the road to get to, the pizza parlor? So the entire idea here is you're just checking to see if you actually cross the road. And your test is if the signs flipped while using IVT. Now remember, I did specify one note at the end of the IVT section where I said, just because IVT fails, so just because it doesn't flip the sign, doesn't necessarily mean you don't have a solution. It just means you didn't cross the x-axis. So it means you touched the x-axis, but it means that, you hit it and then came back. That's the equivalent of, in my example, of you going into the road, but then, turning away. So the idea here is we're just going to check each solution by picking numbers around your solutions because you need an interval, right? That's how IVT works. So you pick numbers around your solution, so you test those via IVT, and you just see if the sign's flipped. And then the last thing is you find the maximum number of turning points. Believe it or not, the maximum number of turning points is actually the easiest one, and we can actually start there. So the maximum number of turning points is always going to be n minus 1, where n is your highest degree, right? Okay, well, I don't know about you guys, but I don't really want to expand out this whole thing, right? The reason I don't want to expand this whole thing out is because first I'd have to do x plus 2 squared, which means I would have to FOIL, x plus 2 times x plus 2. And then only after I do that, I'm going to get a quadratic from that, right? And once I do that, then I'm also going to have to multiply that whole thing by x minus 3. So you could expand, or you could realize that x plus 2 squared, when I FOIL it out entirely, my highest power, my leading term of that, it's going to be 3 times x squared plus, garbage, right? There's going to be other terms that come out when you FOIL it, but your leading term is going to be x squared, right? That's going to be the highest power that comes out. And that should make sense because you're starting with x to the first, and then you're squaring it. So yeah, that should make sense that your highest term is going to be x squared. So you get an x squared here. Okay, that's fine. And then obviously there's going to be some other terms that fall out, but I don't necessarily care about those. And then we still have this x minus 3 piece. And now once again, you ask yourself, okay, what's going to happen when I actually expand this? And without doing the entire expansion, you know that at some point you're going to be multiplying this x squared times this x, which is going to result in your leading term or your highest power being a 3 and your leading term being x cubed. So you know that the highest power that you're ever going to get with this is x cubed, and then once again, you're going to get some other terms in there. Does everybody understand how I got to this conclusion? Again, I didn't want to expand the whole thing because that's a lot of effort here, and it's a lot of effort that you really don't need to do. The question isn't asking for you to expand, and also, if you're expanding, that's going to make it harder for you to find the solutions later. I know that this was the last part of the question, so you would have answered the other things first, but in any event, expanding here doesn't help you with anything else in the question. So all you really have to do is recognize what your highest power is going to be at each step. So your highest power resulting from the piece circled in red is going to be an x squared, and then you're multiplying that against an x minus 3. So at some point, you're multiplying x squared times x, which gives you a highest power of x cubed. So we know that our highest power here is going to be x cubed, and as a result, your maximum number of turning points is always n minus 1, where n is your highest power. So the maximum number of turning points is going to be 3 minus 1, which is 2. So you could write max number of, and I'm just going to abbreviate, max number of turning points is 3 minus 1, which is 2. So at most, this function is only going to have 2 turning points. Are we all good with this so far? I know that part is slightly confusing if you don't expand it the whole thing, but if this didn't make sense, what I was doing here, kind of like a pseudo expansion, if you will, where I was only caring about the first term, then feel free to expand the whole thing. And you do have the tools necessary to expand the whole thing. You're going to just get a quadratic times a binomial, which is, again, binomial means 2 terms. So you're going to get a quadratic times this x minus 3. And then we know how we distribute that, right? You take each piece of the binomial and multiply it against each piece of your quadratic, and then you simplify your terms. So you could expand the whole thing, and that's totally fine, and then you'd realize that x cubed is your highest power regardless. So that's going to be your turning point as far as that question is concerned. So the other questions are find the real solutions and state their multiplicities. So finding the real solutions means you're taking each factor and you're setting it equal to 0, right? That's how we find solutions to a function. That's how we find our x-intercepts. So we have x plus 2 squared, which tells you that you're just going to have x plus 2 times x plus 2. So I'm only going to write it once. You could write it twice, but why would you, right? So you have x plus 2 is equal to 0. You also technically have 3 is equal to 0, but you know that this is nonsense, and that's not going to result in any intercepts, any solutions for your function. And last but not least, we have this x minus 3 piece is equal to 0. So now we solve, and we get x is equal to negative 2, x is equal to 3. And you just ask yourself, okay, we need to state their multiplicities, which I'm just going to abbreviate as m. So their multiplicities here, well, that's asking you how many times do you get this solution. So we only have x minus 3 listed one time in our function. That's the only time that we get that factor, which leads us to say that's the only time that we get that as a solution. So our multiplicity for x is equal to 3 is just 1. Then over here, for x is equal to negative 2, our multiplicity here is going to be 2. And the reason that our x is equal to negative 2 as a multiplicity of 2 is because, again, notice that we have that same exact factor twice. X plus 2 squared is the same thing as x plus 2 times x plus 2, which tells us that because we have that factor 2 times, we have a multiplicity of 2 at that factor. Okay? And this should make sense that you're getting, it's essentially 3 total multiplicities. You have 2 here and then 1 here, because how many is the max number of factors that you could get from this function? Well, the max number of factors that you could get is 3, right? We already established when we talked about turning points that your highest power in this function, when you expand everything, is going to be x cubed, right? And I always told you guys that the max number of solutions that you could get for a function is based upon your highest power, right? They're equivalent. So if your highest power is 3, then the max number of solutions that you could get is 3. And when you get something that has a multiplicity of higher than 1, that essentially counts for multiple factors. So we have x is equal to negative 2, which is only one factor, but it's occurring twice. So we do still end up with essentially 3 factors here. Okay, so that is how you find your real solutions in the multiplicities. And then last thing that we have to do, and probably the most time-consuming part, is state whether or not the graph crosses or touches but does not cross at each solution. So what you want to do is you want to pick test points, essentially. You want to pick an interval around each of these solutions. So you're going to pick numbers that fall around negative 2, and you want to pick numbers that fall around 3. And you're going to test those numbers in IVT, and then that way it'll tell you if the sign's flipped. If the sign's flipped, then yeah, it crosses the x-axis. If the signs don't flip, then it never crossed the x-axis. It only hit the x-axis at that point, and then, stayed either negative on the y-axis or positive on the y-axis, wherever it was, coming from. So let's go ahead and pick some points here. So for negative 2, I'm just going to make my life easy. I'm just going to pick the interval from negative 3 to negative 1, right? So may as well. So negative 3 here. Let's go ahead and plug this into IVT. So this tells us we're going to plug negative 3 into our function. So plugging negative 3 into our function, that means that we're going to have 3 times negative 3 plus 2 squared times negative 3 minus 3. Okay, so simplifying this, we have a 3 on the outside. And actually, you know what, you could do the exact same thing here as we normally do with test points, which is just go by the signs, right? We don't care whether or not we get negative or positive for just one individual piece. We care about the end result. If the end result is negative, then that's great. And then when we test the other one, the other end of the interval, so when we test negative 1, then we care about if that's also negative or positive. So we know that 3 is always going to be positive, so that's positive. We know that it doesn't matter what you're plugging in here. We plugged in negative 3, but we're squaring it, right? Negative 3 plus 2 squared is always going to give you a positive number. Negative 1 squared, which is what negative 3 plus 2 is, when you square that, you just get positive 1 back. So you know that regardless what number you plug in, you're just going to get a positive here because you're squaring it. And then you just have this last piece, which is negative 3 minus 3, which is negative. So at the end of the day, you say, okay, yeah, this is going to be a negative number. So, okay, we tested -3, we got a negative number. Now we test -1. So we plug -1 in, we get 3, we get -1 plus 2 squared, and -1 minus 3. Okay, so what does this tell us? This tells us, again, we get a positive for 3. 3 is a positive number. We know we're going to get a positive once again because we're squaring. And for this piece over here, -1 minus 3 is going to be a negative number again, right? So that tells us that, okay, since we got a negative number twice by IVT, this is inconclusive, right? IVT doesn't prove to you that there's a solution here because this, the sign of the outputs hasn't changed. We got a negative here, we got a negative here, so IVT hasn't proven that there's a solution here, even if we proved earlier that there actually is a solution. So at this point, you would say, okay, at this solution, which is x is equal to -2, it touches, but it does not cross the x-axis. And now we just have to do the same thing for x is equal to 3. So we pick an interval around x is equal to 3. And just for simplicity's sake, I'm going to pick -1 again because we just did -1, right? So make your life easy. You can pick a number that you've already done as long as you understand how an interval works, right? So I'm picking a number to the left of 3, which in this case is -1. And now I'm going to pick a number to the right of 3, which, sure, we'll just make it 4. And now go ahead and test this and see what we get. So we already know that f of -1, when we test this, and I'll just write it again, we know we're going to get a negative number by the work that we already did above here. So I'm not going to rewrite the whole work, but we get a negative number. And now we just have to test f of 4 and see if we get a negative number again or if we get a positive number. If we get a positive number, then IVT has shown there is a solution here because it has crossed the x-axis. So we plug in 4, and once again we have 3. Then we have 4 minus 1 squared. 4 plus 2. I don't know where I'm getting this -1 from. 4 plus 2 squared. And then we also have 4 minus 3. And we have a positive, and 4 minus 3 gives you a positive number. So we know we end up with a positive. So by IVT, we have now actually shown there is a solution here because it crosses the x-axis. So for your first interval, or for this one here, this doesn't cross, and this one does cross. Does that make sense, guys, on how we established this? The entire idea is we just used IVT to figure out if the sign's flipped. So if the sign's flipped, then hooray, right? You know here that IVT has actually proven to you there's a solution. Over here, IVT has not proven that there's a solution, but that's not the same thing as saying IVT has shown there is no solution. Okay, just because IVT wasn't able to prove to you that there was a solution, we actually knew from earlier that -2 was a solution. It's just that it hit -2, but it stayed negative. And what I mean by that is if I'm just roughly sketching just this part of the graph, x is equal to -2 is right here. This is the same thing as your graph coming up this way, hitting -2, but then turning back away. It never crosses the x-axis, it only touches it. And then over here, we have x is equal to 3, which is our other piece. So x is equal to 3 is going to be, like over on this side. And so it's the same thing as this. And why does this make sense for our sketch of a graph? Well, we already talked about end behavior before, right? End behavior of a function, that was in the last lecture. And the end behavior of this function, when we expanded this, we knew that our highest power is x cubed, right? We knew that our highest degree here is going to be a 3. And we know that x cubed has an ending behavior of the right-hand piece going off to positive infinity and the left-hand piece going off to negative infinity. And once again, you ask yourself, okay, well, what about number of turning points? And that was the first question that we answered. The number of turning points that we had was 2. And is that the number of turning points that we have in the sketch? Yeah, absolutely, right? We have a turning point here at one of our solutions, and then we have another turning point right down here at some point, right? I told you guys in the lecture, with the tools that we currently have, we can't see exactly when that turning point is happening. We just know that it happens at some point between our two solutions. Anybody have any questions on this? Because the quiz, we're about to take the quiz here. I just want to make sure that we're all good with this question before I set you guys off. Okay, so silence means you're golden. So I'm going to assume you guys are good to go. Feel free to go ahead and check Blackboard. Make sure the quiz is up. Again, I told you guys that Blackboard was fighting me last night. So please make sure that the quiz is available for you guys. And assuming it is, then you guys can go ahead and start. If you guys do have problems accessing the quiz number 7 for whatever reason, please let me know, and I will take care of it by just sending it to you personally, and you can take it that way. Okay, so I'll just email it to you. But otherwise, you guys are clear to start your quiz, and I'm going to go ahead and stop sharing my screen now.
You posted the answer key.
Did I? Did that happen again?
Mm-hmm.
Fantastic. All right, guys. You know what? We'll just do this. No quiz today. How about that? Enjoy your Friday. That's just the best solution here. So no quiz. And that way you guys can just focus on your midterm corrections. And we'll just end class early today. It's 11:25. You guys get back 25 minutes of your lives.
Thank you. I hope you have a good weekend.
Thank you. Have a good weekend.
Have a good one.
Weekend.
Have a good weekend.